Now I request Manish Shirurkar ma'am to start the session.
Hello, I am Mrs. Manasi Shirurkar, Assistant Professor, Maharashtra Education Society's Institute of Management and Career Courses, Pune, extend my warm welcome to one and all. There is a famous saying, tell me I forget, teach me I may remember, involve me I will learn. FDPs are meant for these only. The more you involve in various new teaching learning technologies, the more learning activities and the knowledge sharing probabilities becomes higher. So, on the same line, we would start with our session 1. The keynote address for this session will be delivered by Dr. Manish Gupta sir. I would like to give a brief introduction about sir. Dr. Manish Gupta is a co-founder and CEO of VideoCane, a video technology startup, and also the Infosys Foundation Chair Professor at IIT Bangalore. Previously, Manish Sir has served as Vice President and Director of Xerox Research Center, India, and has held various leadership positions with IBM, including that of Director, IBM Research India and Chief Technologist, IBM India South Asia as a Senior Manager at, at IBM TJ Watson Research Center in Yorkton Heights, New York. He led the team developing system software for the Blue Gen L supercomputer. IBM was awarded a National Medal of Technology and Innovation for Blue Gene by US President Barack Obama in 2009. Manish Sir holds a PhD in computer science from the University of Illinois at Urbana-Champaign. He has co-authored about 75 papers with more than 7,000 citations in Google Scholar in the areas of high-performance computing, compilers, and virtual machines and optimizations. While at IBM, Manish Sir received an Outstanding Innovation Award, two Outstanding Technical Achievement Awards at the Low Gretzner Team Award for Client Excellence. Manish Sir is a Fellow of ACM and the Indian National Academy of Engineering and a recipient of a Distinguished Alumnus Award from IIT Delhi. Sir, we are obliged to have you as a keynote speaker. Welcome you again and request you to start with the keynote address. Over to you, Manish, sir.
Okay, thank you for the opportunity. Hope you can hear me okay.
Yes, sir.
Okay, yeah, so thanks. So I'll be talking about our work at Google Research India on, again, advancing the field of AI and applying it to problems inspired in the Indian context. And through this work, again, we also hope to have impact beyond India. So, so today, I mean, you've all seen again technology and in particular artificial intelligence really changing the face of the world. There are certain parts of the world where the self-driving cars are beginning to appear. And again, I mean, it'll be a while before self-driving cars work in India, but someday we will see those in India as well. It's only a matter of when, not if. We've already seen, again, if you go to any kind of a car factory, we've already seen robots really taking over much of the assembly line in a car factory. And we have seen, again, in the IT services world, we have again seeing this whole trend known as robotic process automation, where a lot of the functions that have been performed traditionally, things like customer care, as well as managing various servers and storage systems, many of the mundane aspects of those jobs are increasingly being done in software. So, so one of the questions is why now? Why is this whole trend of, I mean, artificial intelligence has been around as a technology for several decades. Yeah, in fact, the field of artificial intelligence is almost as old as the field of computing itself. So one question is, why is this becoming so so talked about at this point? And here's my view of why things are becoming kind of all these technologies and so on, right, are becoming so important. So I draw the analogy with a story that you might have heard when you were growing up. I don't know. I certainly would hear the story a lot. There are various versions of the story where there is a king and there's some famous chess player who pleases the king, and the king said, "Okay, tell me what reward do you want?" And he points to the chessboard and said, "Give me 1 grain of rice for the first square, double the grains of rice for the next square, and keep doubling, and just give me enough for the chessboard." Um, and the king said, "Is that all you want?" And he said, "Yes." And as they went around, kind of, as he went around trying to now get these rice grains measured, the king at some point realized that he would not be able to honor the promise, that he would run out of all the rice available in his kingdom and not honor the promise because there's just not enough rice, right? To as you keep doubling and as you reach the end of the chessboard. So at what point did the king realize he would not be able to honor that promise? Not when you were at the first few squares. It is when you got to the middle of the chessboard that when you started getting into millions and billions of grains of rice, that the king realized this is too much. So this is the power of exponentiation. And I would say there's a similar journey that we have been on. And there's something called Moore's law. Again, it's not a physical law of motion like Newton's laws, but this is an observation and a prediction that was made by Gordon Moore way back in 1965, that you should be able to double the number of transistors on a chip with every new generation of the chip. And what we have enjoyed over the past over 5 decades are these exponential advances in compute power. So the compute industry kept kind of competing, kept advancing the field to again in accordance with Moore's law. So every roughly 1.5 years, we would get these computer chips that had twice as many transistors and therefore were roughly twice as much powerful as the previous generation. So I would argue that around the year 2006, in fact, I heard a factoid that in the year 2006, we started producing more transistors as humanity than grains of rice. So I would say that perhaps 2006 was around the time frame analogous to the second half of the chessboard, which is when the king realized we would not be able to honor the promise, that computing started to become so powerful that things that we couldn't even, that we would think of as science fiction, those things became possible through computing. So now, so that has led to this whole re-emergence of artificial neural networks in the form of this technology called deep learning, right? That I'm sure all of you would have heard about. So artificial neural networks were again, I mean, have been around for several decades, and in fact, in the 80s, the whole computing community gave up on artificial neural networks. That yes, they are an interesting idea, but they don't work. But now, with the power of computing, they made a comeback around the year 2011. And now, again, deep learning is really driving the whole area of artificial intelligence in a major way. So, what are these artificial neural networks? So, these are very, very simple, basically mathematical units that are organized. There are collections of these mathematical units that are organized in layers. And And what happens is, so when you feed, let's say, the data, let's say you have this image of a cat, so that image, the electronic version of that image, right, shows up in the form of, let's say, a particular file, a JPEG file with all these values corresponding to different pixels. So as these pixel values are fed to this artificial neural network, uh, there are very simple mathematical computations being done on those pixel values, and you have again this whole collection of different mathematical units which are organized in these layers. And as you do all these computations, at the end comes this whole output of this artificial neural network, where it is able to classify this image automatically, right, in terms of, let's say, categories. And it is able to learn this function that when fed the data corresponding to the image of the cat, the output of that artificial neural network would be this category, that this is a cat. So these artificial neural networks, these deep neural networks, have been able to do a number of things. This example that I just mentioned, where the input is basically a collection of pixels corresponding to the image, they can convey this output function, which is saying what kind of an image it is, right? Hussar monkey. The input could be audio signal, and the artificial neural network is able to learn the output, and the output could be in the form of now the text corresponding to the speech, right? So this is the problem of speech recognition. Given an audio signal, you output what is the text. Another example, you could give input in this language, let's say English, and the output function could be the same, again, sentence in a different language. Here, this is French. So this is the problem of language translation, right, which is being, again, done by these deep learning systems. And finally, a more kind of a complex version of this image classification problem that I talked about, you could feed this deep learning system this image of, let's say, this particular photograph, and it could come out with the output, a blue and yellow train traveling down the tracks, right? So it is coming up with an option, with a caption describing this image, similar to how a human would have done it. So how's all of this getting done? Is this magic? No, it's not really magic. I mean, back to this particular neural network, essentially what you are doing is you are training this neural network by really identifying the various weights that are to be kind of in each of these mathematical units, in each of these neurons, and essentially, as you kind of do this final computation, right, you initially typically feed it label data, right? So once you have, let's say, fed those images, let's say this is an image of a cat, and you assign a label cat, let's say, to this image. Likewise, you have lots of images of dogs, and you assign the image the label dog, and there could be images of cars, and you assign that label car. Essentially, what you do is you are, through those mathematical operations, you're finally producing this output. And essentially what you are doing while training this network is you are using that label data, and using that label data as kind of training data, and you're training your network to kind of minimize the error, that whatever were the weights and so on that you multiplied, and you kind of say that the answer should be cat, and you typically, again, pose this as an error function, as a loss function, that whatever is the difference between the predicted value of the function and the actual value, you call it the loss function, and then you optimize that loss function with respect to all of these weights. And again, I mean, Jeff Hinton, who got the Turing Award, one of the Turing Award winners recently for his pioneering contributions to deep learning, he showed again these efficient uh, techniques called backpropagation and so on, through which you were able to very efficiently learn these weights and train the neural network, right, to be able to do this. And through this, again, you're able to train different kinds of neural networks to do these amazing things, be able to do image classification tasks, speech recognition tasks, uh, language translation, and things like coming up with a caption. I'd like to make it maybe interactive and see, are there any questions at this point before I proceed?
Hello.
Yeah.
Sir, questions will be asked at the last.
Okay.
Before signing up, before leaving the session, we'll give 10 minutes for Q&A
Okay.
session.
Yeah, no, I mean, just in case, because this is really, in some sense, the basis for a lot of AI, which is AI, various applications, and so on. I just wanted to understand at least this basics were well understood. So I just wanted a sense of, are people already familiar with deep learning? And if they are not, is this basic, this whole basic foundation of deep learning, is that clear, or should I go more into the foundation? Because otherwise, I'm going to get two applications of deep learning.
Uh, Sir, we'll proceed further. At 11:20, we'll cover the question.
Okay. Okay, so now let's. So what we have done is, again, the research community has been now applying these techniques in things like deep learning and other techniques behind machine learning to various applications in areas like healthcare, um, education, agriculture, water conservation, and democratizing access to information in Indian languages. And in the process, I mean, one of the things we are also doing is also doing fundamental research on AI, because there are also these interesting issues that arise when you start applying AI to real world problems. So as you start applying AI, one of the things is to things that affect human lives. One of the concerns is that you could be creating potential problems. So let me give you an example of one problem, which is creating or reinforcing unfair bias. Because some of these issues led to these Google coming up with these AI principles that we will always pursue these applications in a manner that are consistent with these principles, right? That these are socially beneficial, they avoid creating or reinforcing unfair bias, they are built and tested for safety, and so on. So let me give the example of how an AI system can reinforce bias. So today you hear about AI applications which uh, are today kind of helping companies shortlist candidates, right, for hiring. So an let's say if I'm designing an AI application which processes these resumes and automatically decides which applicants have a strong resume and should be shortlisted for further interviews. Now, to train this AI system, I would start by looking at label data of and training data, right, of how human recruiters, right, have processed these resumes, right, and based on what they did, I will train my AI system accordingly. Now, if you were to simply go with that, it is possible that the human recruiters themselves were biased. There have been numerous studies that show in the world of information technology that often women have been at a disadvantage. If you kept everything in the resume the same, but simply changed the name from a male to a female name, there are numerous studies that show that the chances of that resume getting selected for the information technology job go down. So now, if that is indeed the case of how humans have done it, and this you use that data to train your machine learning model, then you're going to perpetuate that bias. And now this AI system, when it processes these resumes, it'll also basically without explicitly kind of being trained, without by explicitly using such a rule, it may end up discriminating against women. So how do you ensure that you do not create such biases? So there are now technologies being developed. So for instance, Google has released this whole open source framework called TensorFlow for developing these different deep learning applications. So there's something that we have also released called TensorFlow constraint optimization, where while training the machine learning system, you can also impose constraints like, oh, the percentage of false positives on male candidates should be roughly equivalent to the percentage of false positives in female candidates, and likewise the percentage of true negatives, true positives, and true should be roughly equal for the male and female applicants. So through this, you can try to reduce the kind of bias in the system. So let me move on to again start with an example of healthcare. That every country on the planet is trying to improve its healthcare system, and including US, which ends up spending over $10,000 per person on healthcare, down to again a country like India, where the amount of spend we have per person is very low, but that's because we don't have decent healthcare being provided to much of our population. So as India goes around providing healthcare to its entire population, we cannot afford to make the mistakes of countries like the US. We have to build a better healthcare system. And in my view, that better healthcare system is something that A, focuses on delivering value to patients as consumers, and B, which is proactive, which is able to emphasize wellness and try to have proactive action being taken. Uh, so, so as an example, I mean, if you're treating a person in an ICU, that's a very expensive place to treat a person, and if you can actually take care of them before they need to enter the ICU, it leads to better outcomes for them as well as lower cost, right? So there's this saying, prevention is better than cure, that really applies to all of the different tiers. So AI in particular can help us more proactively identify various healthcare issues and therefore be able to achieve better outcomes. So let me give an example of screening for a condition like diabetic retinopathy. So diabetic retinopathy is now a growing cause of blindness of people, and it can potentially affect any person with the diabetes condition. So India in particular is the diabetes capital of the world, where we have a very large number of people, well over 75 million people affected by diabetes. Um, so regular screening is key to really preventing blindness from diabetic retinopathy. Now, in a country like India, a problem we have is that we have a severe shortage of eye doctors. You look at any specialty and we have a shortage of doctors with that specialty. So what ends up happening is that in India, roughly 45% of the patients end up suffering a vision loss before they are diagnosed with this condition. So our team went about looking at, could you apply AI to assist again these doctors in making this diagnosis? So how's this condition diagnosed today? basically you take the image of the retinal region using a special camera called retinal fundus camera, and the eye doctor basically looks at this image and they look for signs of hemorrhage to really diagnose this condition. And they rate this image then on a 5-point scale, 1 meaning no diabetic retinopathy, and 5, which is high level of diabetic retinopathy. Now, so what our team of AI researchers did was they started to see, could you apply all these deep learning methods to take these images and automatically grade them on this 5-point scale. So similar to how deep learning methods were applied for this image classification, right, to distinguish between images of cats and dogs, similar kind of techniques got applied to this 26-layer network, and it was able to then come out with these answers: no diabetic retinopathy, mild, and so on up to proliferative. So this team again then published a paper in this well-known medical journal, JAMA, in 2016, where they showed results that were comparable to that of a general ophthalmologist. And this paper again received a lot of praise from the medical community. So the work was done by a researcher called, it was initiated by a researcher called Varun Gulshan, who's shown his photograph. So he had actually moved to India for personal reasons, but he continued working with his Google research colleagues in the US and initiated this work. And this paper was recently rated amongst the 10 best JAMA papers in the last decade by this reputed medical journal. So again, it shows again how deep learning is helping us with some of these really complex problems like diagnosis of diseases by analyzing those images. And more recently, the team kind of did further improvements, and in the next year they published a paper that showed results comparable with the retinal specialist. Now, I will caution that it is, while these results are very impressive, one shouldn't get carried away with the hype. And it doesn't mean deep learning has solved all problems. There are still a number of challenges. So in particular, researchers are addressing challenges in terms of how do you explain the results of these deep learning systems. And also, unlike humans, that if a human is presented a very complex case, they will say that, look, I'm not sure about this case. Whereas a deep learning system, when presented with a very different kind of data than what the data it was trained on, might make a mistake and make it very confidently. So you cannot afford those kind of mistakes in areas like healthcare. So let me kind of speed up in the interest of time and maybe conclude with a couple of more examples. Another thing that we are doing is we have this AI for Social Good program, where we went to NGOs working in the areas of public health, wildlife conservation, and education. And we asked them, okay, tell us what are some of the challenges that you're dealing with, and let's see if AI can be applied to deal with some of those challenges. So one area in which we applied it was for maternal and child health with this NGO called Arman. So they have this program called Emitra, which is trying to improve health of expecting mothers and also their babies when they are born. So what they have is a free mobile voice call service. So for every week of the pregnancy, 2 voice messages get delivered through a recording that is played when the participant picks up the phone. And this message has helpful tips about what to watch out for during that week. What, let's say, dietary supplement, for instance, during this week, you should take an iron tablet to reduce the risk of anemia. And they showed that for women who stick with this program, it does lead to better outcomes for them and their babies. But the unfortunate part that they told us is that roughly half of the women end up dropping out of this program. So average engagement rate is only about 50%. So they asked us, could you predict which women were at a high risk of dropping out? And together with IT Madras, we developed these AI models that were able to do those predictions. And we found that our predictions were successfully identifying over 80% of the women who were actually dropping out later. So this particular AI model has been deployed in production at Arman. And based on its predictions, now Arman reaches out to those women at a high risk of dropping out in a special manner to be able to, again, keep them engaged. Likewise, another example is this is work done by my colleagues in Google Israel, but they started this work in India on flood forecasting. That can you build again a machine learning model which is able to, given data about precipitation and given water level readings, it is able to come up with predictions for flooding. And again, this model was tried out in certain regions of Bihar. So this data is for a certain region in Bihar on the Ganga River. And you can see that, again, so precision and recall are terminologies in, again, machine learning, where you try to look at how many percent of the actual flooding events were you able to capture. So the traditional techniques, they had a recall of 31%. That means they were only able to successfully identify about 31.8% of the actual flooding events. And when they said that this is a flooding event, the precision was only about 19.7%. So that means you were only right about 20% of the time that there is actual flooding happening. With this machine learning model, we have been able to substantially improve the accuracy of that flood forecasting model. And now that is being now deployed in many parts of India. And these alerts are being sent. So we are doing further work with analyzing the satellite images to be able to solve problems like land use, land cover classification. Can you, for each point on the map, can you automatically classify, is this a forest or a grassland or a water body or an agricultural field? And with this kind of analysis, which we are doing with the Google Earth Engine team, the idea is you can do some very interesting analysis like what's happening to the forest cover in a given region, what's happening to water bodies, and uh, and further techniques as you apply them to satellite images of crops and automatically classify what crop is being sown and so on. You can start to then solve problems in the area of agriculture. So, for instance, how do you help provide farmers easy access to credit and crop insurance at a lower price point? What is very important is to be able to tackle some of these problems like estimating what crop is being grown, estimating the yield, and so on in a very at massive scale in a very cost effective manner. And again, satellite image analysis gives us that promise that potentially you could do that analysis at the entire level of an entire region, entire state, and even the entire country at a much lower cost than having to do that all of that manually. Now, final example I would give is democratizing access to information. So I'm sure all of us who are attending the session, we all use the Google search engine, right? Whenever we are looking for some information. Now, this works very well for those of us in this room because we are able to understand English. And Google search engine works very well, right, for various English queries. One of the goals we have is how do we make such access to information work even for other languages, given that in India, only about 10, slightly over 10% of the population actually speaks English? How do we support access to information for that farmer in Haryana who may not understand English, or for that child of a laborer in Assam? How do we access to information in that child's native language, Assamese? So that is something that we are taking on as a challenge. That how do we effectively support things like search, creating knowledge graphs, as well as things like language translation for different Indian languages. So again, I mean, here there has been this technology called BERT from Google Research, which has really kind of made a huge difference to many, many natural language processing applications, including Google search itself. Um, and the idea behind BERT, it was a very interesting idea that you took a lot of the text that you already had, something like, let's say, this text that you might get from Wikipedia, and you blank out roughly 15% of the words. And then you ask this deep learning model to try and fill in the blanks, right? Just like we used to provide these problems, right? Solve these problems in our English class in school, fill in the blanks. So you ask this deep learning model to fill in the blanks, and you already know the answer from the original text. And in the process of training this deep learning model to fill in the blanks, this model ends up learning uh, a lot of very important characteristics about how to take advantage, how to understand the context, how to understand different words. So it starts to come up with good learning representations for these languages. So what our team did was, when we looked at, again, a multilingual version of BERT, because in India we speak many, many languages, and often we even mix multiple languages in the same sentence. We found that it wasn't doing as well on Indian languages. So we developed our own representation called Mural, multilingual representation for Indian languages, with which we were able to significantly improve the accuracy of some of these uh, natural language processing tasks, like named entity recognition, part of speech tagging, and so on this. So let me stop here. What I have done is given you some examples of how AI can be applied to tackle problems in areas like healthcare, in access to information, and in areas like agriculture. But again, I mean, this is only the tip of the iceberg. There are huge opportunities as the computing field continues to evolve, and as the technology of AI continues to evolve, for us to start applying AI to many, many problems that we have not even kind of thought about today, and start making a difference, right? And making the world a better place. So let me stop. Take some questions if there are some questions.
Thank you, Manish sir, for such a valuable and knowledgeable session. I hope each and every participant will get good knowledge from the session. I request all the participants, if you have any questions, please write in the QA session box.
Mukul sir,
So
Yes,
that,
sir.
sir,
Mukul sir, there is one participant is raised the hand. So can you unmute him so he can ask the question?
Already done, sir.
Yeah, so very good morning to all. This is Dr. Biswas from Central University of Jharkhand, Ranchi. So it is indeed a very informative presentations. I thank you, sir, for your valuable inputs. So my question. So as you are saying that you can use this deep learning process for medical, healthcare system. So how far the government of India is using this healthcare, this module, or whether is there any data available in India so government can use for healthcare system? Because you see in India today, for example, in rural area, we don't have much medical facilities. In that condition, what would be the policy of the government to how to reach to every individual? So through the process or through data. So I want your
Yeah, so that's a good question. So what is happening today is that, as you observe, right, this data needs to be in electronic form for you to really start to apply these deep learning AI methodologies, right, to this data. So what is needed is, as India goes about developing the healthcare program, right? So we have heard about this National Digital Health Mission. So the government has announced this National Digital Health Mission, and there is this national health stack being defined. So there are a lot of initiatives underway through which the government is encouraging the creation of these electronic healthcare records that could be accessed by each citizen as a consumer. So back to your question about, let's say, in villages, what could be a starting point? So in my view, the starting point could be these mobile devices, smartphones, that even though we don't have good, often medical facilities, there are smartphones that are now becoming available, right? Which these ASHA workers and so on, right, that provide healthcare in rural areas, they can be equipped with smartphones. Now, with the help of smartphones, there's a fair amount of health parameters that can be collected. So for instance, I mean, in addition, you will need, I mean, often to, like, you will need basic things like collecting the body vitals like temperature and so on, but there are even technologies that are coming up where through a smartphone you would be able to capture certain body vitals in a kind of a non-intrusive manner. So the basic thing that needs to be done is to, and also, let's say each smartphone has a camera. Now, by taking a photograph of the person, you can start to apply AI to start to infer. So, for instance, is this child really malnourished? You can start to apply some of these AI techniques to start inferring. And when you, let's say, take the image of a particular skin, on the skin, is there a particular problem, right, with that particular, is there a skin problem, right, that needs attention and so on? So there are many of these kind of problems which you can now start to analyze based on the data that you can collect from a mobile phone. So in my view, this mobile phone can be a starting point, and there has been work done at Google Research. So we have a partnership with Bill and Melinda Gates Foundation, where we are trying to equip these ASHA workers with more sophisticated applications that run on these smartphones, through which you can start to do basic kind of health parameter collection of people, and then start to build those electronic health records, as well as then start to provide some aids to the healthcare workers about diagnosis of these conditions, and provide some suggestions for what could be a effective treatment for those. So the idea is, I think, with India, as we build the healthcare system, the more we can emphasize prevention. So one of the things we are also doing is, a lot of these conditions like heart attacks, strokes, and so on, they can actually be prevented or significantly delayed by adopting healthier lifestyles. That please exercise more, eat good helpings of fruits and vegetables, limit your salt intake to no more than 5 grams per day, and so on. So can you have all these wellness apps on these mobile phones, right, that encourage people to adopt healthier lifestyle? That's another way in which our disease burden could be reduced. So these are some initial thoughts in terms of how AI can be applied to healthcare.
thank you very much, sir.
Sir, there is one more question in the chat box. What can be used for sense disambiguation for Marathi language? Manish
Right.
sir?
So is that a question?
Yeah.
So the question is, can BERT be used?
Yes, can BERT be used for word sense disambiguation for Marathi language? The question is by Chaya Patil.
Right. So the way these things work is they come up with these embeddings, and how close those embeddings are kind of tell you how closely related these words are. So BERT in its original form doesn't do a very good job of covering Indian languages like Marathi, because your question is about Marathi. And this is where this mural framework that we have developed, which covers 16 Indian languages in addition to English, and it does include Marathi. So mural does a much better job than BERT at doing this disambiguation and so on, right, for Marathi words. And in fact, we have released mural again. All these mural embeddings, they are available now in open source on TensorFlow Hub.
Uh, Hello, sir. Good morning.
Good morning.
I also have a question. That might be the question in many of the faculty members. Google Research India is doing lot many work in a different field. Specifically, for example, I am working in education field. Somebody was working healthcare. My question is how, as a faculty member, we can associate with this kind of research, or we can do some collaboration or whatever it may be, because everybody was eager to listen to you on this particular topic.
Right. So right now, for instance, we have a call. So we often have a call for faculty to tell us about their research interests and capabilities, and we include these faculty members in various some of the projects, especially in the AI for social good area. So last year we had started 6 projects, and in each of these 6 projects, we had at least one academic group in addition to an NGO working on those problems. This year, we are planning to start over the next 3 months. We are planning to start another 30 new projects in AI for social good. So we have a call for again contributions where we are reaching out to NGOs to tell us about the interesting problems that they face. We are inviting faculty members to tell us about their research, and then we will do some of this matchmaking. So we will start to bring and we will provide funding to these academic groups to work on problems that have been posed by the NGOs.
Thank you, sir. Thank you very much.
Any more
I see a
questions?
question on the chat. Yeah. Should I just directly address this, or do you want to provide a chance to let this person ask? The
You can
question.
directly address.
Yeah. So there's a question from, I think, Ms. Kritika. Can you tell what are the major drawbacks that are still to be addressed in implementing AI system in education, specifically addressing student skill development? So I think yes, there are a number of challenges, because I mean, as you would have seen, there's a lot of very good content in various areas, right, for skill development, which is now becoming available in the form of online videos, right? So today, you name any topic, there are videos available on that topic. However, there are still huge challenges in how to keep students engaged in this learning, because what happens is, in a lot of online programs, you find thousands of students may enroll, but the percentage of students who actually end up completing the program often is very low, right? No more than 5 or 7% students actually complete. Likewise, I mean, when you start an online video, you may have again hundreds of people watching that video, but then after a few minutes, people kind of their attention span goes away. So that's one area where I think there is a lot of work to be done on how to keep students engaged. And as they run into issues, if the student has doubt, if the student whatever is getting bored, how do you recommend the right content to them so that you keep the students' interest level alive? And then how do you assess the skills of the student. That's another area in which there are many challenges. And how do you impart higher level skills like analytic capabilities, creativity to the students? There are still no good solutions. So there's a lot of challenges still left, right, in how to improve the education system that we have using AI. So I hope this was useful, because again, I have some other engagement, so I need to close this soon.
Yes, sir. I will, if any questions are there, we will forward it on your mail ID. And
Sorry to disturb
if
you, sir.
possible, you
Goche
can.
sir has joined and he has a question.
Sir, actually, Gupta sir wants to.
Okay, yeah, sure.
That's the, because he has agreed up to 11:30 only, but still, sorry, sir, it is it was get extended. I again thank you for giving us an opportunity to hear you, and thank you once again. Thank you very much, sir.
Thank you.
Thank you very much.
Thank you. Bye.
Right. All the participants,